Equation describing the relation between displacement and time. Let us suppose that an object in uniform acceleration a and it has covered the distance s within time t. From the graph in figure 1.9, the distance covered by the object during time t is given by the area of quadrangle DOEB, that is S equals to area of quadrangle DOEB equals to area in bracket rectangle DOEA plus area of triangle DAB, that is S equals to AE into OE plus 1 by 2 into AB into DA. But AE equal to U, OE equals to T and OE equals to DA equals to T. AB equals to AT, AB equals to CD from 1. That is S equals to U into T plus 1 by 2 into AT into T. That is Newton's second equation of motion is S equal to UT plus 1 by 2 AT square. Equation describing the relation between displacement and velocity. We have seen that from the graph in figure 1.9, we can determine the distance covered by the object in time t from the area of the quadrangle DOEB. DOEB is a trapezium, so we can use the formula for its area. That is S equal to area of trapezium DOEB, that is S equal to 1 by 2 into sum of lengths of parallel side into distance between the parallel side. That is S equal to 1 by 2 into OD plus BE into OE. But OD equal to U, BE equals to V and OE equals to T. That is S equal to 1 by 2 into U plus V into T. But A equals to V minus U upon T, that is T equals to V minus U upon A, equation 3. That is S equals to 1 by 2 into U plus V into V minus U upon A. That is S equals to V plus U, V minus U upon 2A. That is 2AS equals to V plus U, V minus U equals to V square minus U square. That is V square equals to U square plus 2AS. This is the Newton's third equation of motion. Always remember, the velocity of an accelerated object changes with time. Change in the velocity can be due to a change in direction or magnitude of the velocity or both.